Bismillahirrahmanirrahim. Welcome to the new topic of functions and limit. By the end of this lesson, you will be able to define the limit of a sequence when the limit of sequence with nth term is given. And you will be able to define the limit of a function and the statement of theorems on limits of sum, difference, product, and quotient of functions. Earlier in this course, we introduced the concept of a sequence as a particular list of numbers. And we looked at some basic types like arithmetic sequences, geometric sequences, and even some more interesting ones like the Fibonacci sequences. And we saw how these can be expressed in a few different ways as beyond simply listing the terms. They can be abbreviated using a particular expression or formula. We also explained to look at series and summation notations. If you have never seen them or you forget about its concept, you must recall them. Since we now understand calculus, so for you people, I'm reinforcing some of the sequences that I just have listed them. But first, proceeding towards those sequences, let's discuss what the sequence is. In previous sections, most phenomena we have considered occur continuously, but in particularly every field of inquiry, there are situations that can be described by cataloging individual items on a numerical listing. Right? For instance, let's take an example. A drug is administered into the body. At the end of each hour, the amount of drug present in is half what it was at the end of the previous hour. We can say mathematicians might refer to the injecting drugs labeling procedure by saying the amount of drugs and they are arranged as in term of sequence. So a sequence is a succession of numbers that are listed according to a given prescription or rule. What is a sequence? A sequence is a list of things, usually numbers, that are in order. So in this sequence, this 3 represents your first term, this 5 represents your second term, so on and so on. Now let's look at the type of the sequences. Here are the few types. I'm recalling them so that you can memorize them and you can relate your problem. Arithmetic sequences. What are the arithmetic sequences? In arithmetic sequence, the difference between one term and the next is a constant. In other words, we just add some values each time onto infinity. So the sequence has a difference of 3 between each number. You can see this example, and if you are subtracting the second term from the first term, you will be getting your difference as 3. And you can check it between every two numbers. Its rule is x sub n equals to 3n minus 2. In general, we can write an arithmetic sequence like this: a plus d, a plus 2d, a plus 3d, where a represents your first term, a plus d represents your second term, a plus 2d represents your third term, and so on. It means that each time you are adding the difference to get your second term. Then it is geometric sequence. In a geometric sequence, each term is found by multiplying the previous term by a constant. So here is the geometric sequence. The sequence has a factor of 2 between each term, right? So its rule is x sub n equals to 2 to the power n. In general, we can write a geometric sequence like ar square, ar cube till so on. Every time you are multiplying the number with r. Then it is Fibonacci sequence. This is Fibonacci sequence. Fibonacci sequence is the next number is found by adding the two numbers before it together. The 2 is found by adding the two numbers before it, that is 1 plus 1. The 21 is found by adding the two numbers before it, that is 8 plus 13. Here is 21 and you will be getting next term if you are adding the previous two terms. And how to get this 2? That is, if you are adding previous two terms of this 2. every next term will be getting if you are adding the previous two terms. That rule is interesting because it depends on the value of the previous two terms. Rule, we also call it as a recursive formula. Then here comes the convergent and divergent sequence. If you are applying the limit on a sequence, then whether that sequence will be convergent or it will be divergent. First, we won't be able to assess whether a sequence is convergent or divergent. So let's find out what that means. Take the sequence a sub n equals n. That means that the first term is 1, then 2, and so forth through the integers. We want to find out what this sequence does in the limit of n approaching infinity. For this one, it's easy to see that the sequence approaches infinity as n approaches infinity. So we would call this sequence divergent because the limit does not exist. Then let's look at something like a sub n equals n over n plus 1. This will give us 1/2, 2/3, 3/4, and so forth. We can pretty quickly see that this sequence will approach 1 but never quite get there. So the limit of the sequence as n approaches infinity is 1. Because the limit exists as a finite number, we would call this sequence convergent. There are some sequences for which it's a little trickier to determine the limit, and with these it may be useful to apply some of the limit laws. We already know as they could help us mathematically things into a form where limit is easier to assess. Sometimes we can use special techniques like using L'Hopital rule on the related function, or something called the sequence theorem. This one says that if there are three sequences A, B, and C, and B is always between A and C, then if A and C both have a limit of L, then B must also have a limit of L, because it is being squeezed in between these ones. Some sequences would be divergent without going to infinity, like -1 to the n power. This just alternates between positive and -1 forever, so there is no limit. So once again, we look at what a sequence does as n approaches infinity. If the sequence asymptomatically approaches some finite number, it is convergent. If it does not, then it is divergent.